the CPU usage in the tray icon. If I see the CPU usage green, solid green for a period of time, I know that something's burning my CPU. Why is that bad? Even if it's not causing sluggish performance, if I'm on a laptop, it's burning my battery. My power is going to run down a lot faster than it would otherwise. One of the unfortunate things, in my opinion, of the multi-core revolution, where now everybody's got at least 2 cores, even people that are walking around, we don't have them on netbooks yet, but I'm sure we will in the near future, is that if you've got a runaway process, you don't necessarily feel it. It's there burning your CPU, you're cruising along, and the other core, you know, the system's not as fast as it otherwise would be, but it's really typically hard to tell that that's going on. In this particular case, the guy had 1 CPU, and it's very easy to tell when somebody's pegging the CPU and you've got a 1 CPU system. Everything starts to get slow. So he noticed the sluggish behavior. He pulls up Process Explorer and he sees that the process in question is WMI-PRVSE.exe. And you can see that it's been burning CPU for a while. That's the mini graph there that's at the top of the Process Explorer window showing it's been green for quite a while. Anybody know what this process is? It's the WMI provider host process. Now the problem here, he's kind of stumped. That's a host process. A hosting process is one that can host other components. And there's a number of different types of host processes. You can see there at the bottom. Service host hosts Windows services. Internet Explorer hosts third-party plugins. MMC hosts a snap-in DLL or more. At DLL host loads a COM server DLL. Run DLL 32 loads a control panel DLL. All of these things, when you see these processes and you suspect that they're a problem, they're not typically not the problem. It's usually something they've loaded because they're just containers for the most part loading this other stuff. So his job wasn't done at this point. WMI provider service, what inside of it is causing the problem? It's probably not that executable. It's something inside of it. So you need to turn to threads. So let's just briefly talk about a process and threads. A process is a container. It has an address space associated with it, a security context that we've talked about and saw in the Process Explorer properties. It's got a handle table associated with it, which the operating system uses to keep track of open operating system resources. It's got a number of different performance characteristics or attributes that are kept that you can look at in things like perfmon and Process Explorer. Processes don't actually run. It's a thread in the process that run. And each process, every process on the system has at least 1 thread. Typically, they have more than 1 thread. And it's the threads that actually are given CPU time that execute the code in the process. Every thread shares the entire process container. They're all buddies in the same family. They can mess with each other. They all have equal access to the handles and the address space. 1 bad thread in the process, and all the other threads are affected. That's the nice thing about a process. It is a reliability boundary. So 1 bad process doesn't affect other processes typically. So how do you take a look inside of a process? You need to look at the threads. Now you notice that I've got something burning my CPU. And if I zoom in here on the tray icon, it's service host. This is the tooltip showing me the process at the time I hover that was consuming the most CPU. And it's a service host process, which is a Windows service hosting process. Let's go find which one it is. And it's this service host. You can see it's consuming about 55% CPU. The thing about Process Explorer and most container-type processes is it will show in the tooltip the components that are loaded into that process. For example, for service host, it will show me the services that are running inside of that service host. For Internet Explorer, it will show me the tabs running inside for Internet Explorer 8 because it's got a multi-process model. And do I have any other hosting processes running at this point in time? It doesn't look like I do. So if we had a run DLL or a DLL host, it would also show us information about those. Service host being a container, my job isn't done here. Let's go take a look at the threads now inside of this service host. Now one of the things, let me close this up for a second. One of the things that Process Explorer can do for threads, each one of these lines represents a thread in the process, is display start addresses for those threads. The way that it most useful way to use Process Explorer is to configure Process Explorer to reference symbols from the Microsoft symbol server so it can pull down function names for the Microsoft binaries that are in the box. And that's why you see for the highlighted line, service host wmain CRT startup, is because I've gone over here to the options, configure symbols, and I've pointed it at the public symbol server. No need to write this down. This is documented right in the debugging tools for Windows help page, or in help file it says this is the URL. It's been this way since like 1998 for the public symbol server, so I've gotten really good at typing it really fast. If you don't have symbols for the image, then what you'll do is just see a raw offset, and it looks like I've got symbols for everything in here, except for this process, this thread right here, where you can see it's got this weird offset here. It's because I don't have symbols for it. So which threads are consuming the most CPU? Well, this one, service hog. It's pretty obvious that we know what this is. This is a DLL here. If we double click on it, if we click on the modules tab, then it will show us information about this particular DLL, that it's a service host CPU hogging demo program, which isn't surprising given its name. It's pretty straightforward. I wrote it back in 2004. I'm pretty proud of this little program. So that is ideally the case that you run into, is that the thread start address tells you right away what's going on with that particular thread that's consuming CPU. It's a third-party component. Let's go ahead and freeze that one, and I'm going to suspend it, which you can do with threads. Now, this you should only do in a pinch when you know exactly what you're doing. I'm a professional driver here on a closed course, so I'm free to suspend this. Like, your mileage may vary if you're going around suspending random things on your system. But we've got one other process here, one other thread here going crazy. We'll come back to that in a second. Let's go see what happened with the case that we're looking at when the user, or the administrator, went and looked at his WMIP provider service process. The thread that was using CPU had its start address in kernel 32 and the create thread function. This is a generic start address. This is really the start address for every single thread. What this says is that this started in a generic thread function that's called into something else. So at this point, he doesn't, no more clues yet. Still looks like system stuff, but he suspects that it's a third-party plugin. He needs to dig even deeper into this process to see what that thread is doing right now. And the way that you can do that is by looking at the thread stack. How many people have analyzed a thread stack? So a few of you have. Now, it's really pretty straightforward. You know that programmers divide their code up into functions. And functions are even implemented in separate images, different DLLs. When one function calls another function, typically it wants to pass it some arguments, some parameters. And then when that second function finishes, that function needs to know how to get back to where it was called from in the first function. The place that it stores that information is in the threads stack. And so what it'll do is put the arguments on the stack, call the function, and the call operation itself sticks the return address to function 1 in the stack. Function 2 then goes and looks at the arguments, does its thing. When it's ready to return, it finds the return address on the stack and continues execution there. So you can look at the stack at any point in time and see kind of the history of the way functions called each other. Here, function 1 calls function 2, calls function 3. You would see that in the stack. Let's take a look at the call stack now for this thread that we've got consuming CPU. And you can see that it started in NTDLL, TPP worker thread. This is just a generic thread pool worker thread, part system thread. But it's obviously consuming CPU. Some other component is feeding this worker thread work to do. What is that work? Who is it? Let's take a look at the thread stack. And what you'll do with the thread stack, you read this from the bottom to the top in terms of time. The thread started its life in NTDLL user thread start, which called base thread init thunk, which called TPP worker thread, which you can get the idea, called into service hog, and service hog is called into get tick count stub. the key here is to look for suspicious DLLs. What DLL looks suspicious in this thread stack? Service hog, right? It's a third-party DLL, obviously, and third-party DLL is typically what you're looking for.